So here for principles of ecosystem ecology, we're going to continue on and move on to Chapter 2. And Chapter 2 is an important chapter because it talks about Earth's climate system. The first section is the introduction, where we are introduced to the Earth's climate system. And the authors have a very important statement here. They say, climate exerts a key control over the functioning of Earth's ecosystems. As far as the state factors are concerned, climate is the most important state factor for all intents and purposes. More attention is paid to climate than probably any other state factor. It has incredible control over how ecosystems function. And so if we're going to pay attention to any one state factor, we should probably pay attention to climate. The authors also state that understanding the causes of temporal and spatial variation in climate is therefore critical to understanding the global pattern of ecosystem processes. So when we compare ecosystems on a global scale, one of those factors that we really have to take into account is the climate in those places. And when we're starting to think about global ecosystems and how they work, we have to think about the climate and the climate system, how they interact. Now, as far as definitions are concerned, climate is the typical meteorological conditions in a given region over a relatively long period. So when we talk about climate, we're saying this is something that typically happens here meteorologically. Now, the difference between weather and climate is not a categorical difference. It's more of a continuum. And this is a time scale, for example. And so when we think about variation that we see in weather, that these are relatively short time scales, days, weeks, even on the order of a month, something like that. If we see variation in temperature, precipitation, and we talk about how temperature has changed over the past week or two, then we're talking about weather. As we go to longer and longer time scales, then we're into climate. We're into what's typically happening. When we talk about interannual variation in weather, for example, when we begin to work on, I would say, the interannual scale, so somewhere on the order of 1 year, we can talk about interannual variation in climate. So if we say 1 year it was this and 1 year it was another, we're not really talking about interannual variation in weather, we're really talking about climate. And at least empirically I've found when we're starting to work on the annual time scale, comparing years, then we're talking about interannual variation in climate. Anything less than that, we usually talk about weather. So if we're saying the difference between June, July, and August of 2013, that's weather. If we're talking about comparing 2012 versus 2013 in the temperature precipitation, we're then starting to think about interannual variation in climate. So it's hard to kind of separate these at certain points, and usually 1 year is a good break point for the two. But know that as we get into longer and longer time periods of comparisons, we're starting to build up what's typical and what's variable. Then we're into climate. Now, climate is composed of many different factors. So we're working on relatively long time scales, and there's a bunch of factors that go into determining the climate of the place. If we want to describe the climate of a given region, we're going to talk about the cloudiness that's there. We'll talk about insolation, so how much sunshine does it get? And then we'll talk about temperature and precipitation, two of the main factors that we normally think about when we think about weather and we take a look at a weather forecast. But in addition to all of these, humidity, atmospheric pressure, wind, all of these are components of climate that are not independent of one another, but they're separate factors that we think about. So when you look at a weather forecast, you'll want to know how hot it's going to be. Is it going to rain? Is it going to be sunny or cloudy? Those are things that we think about for weather. Maybe the humidity, is it going to be humid? Is it going to be dry? All of these things, when we think about over relatively longer time scales, are what we think about for climate too. Now, of the climatic factors, temperature and precipitation, far and away, are the two factors that we think about most is impacting ecosystem processes. All the other ones do too, but usually when we categorize or characterize different ecosystems, and we want to think about plant production or decomposition, the weathering of rocks, development of soil, those things that ecosystem ecologists think about a lot, we're really going to start with temperature and precipitation. And those would be the two main climatic factors for this book and for the course that we're going to focus on. Now, that being said, we still have to think about humans and how humans are impacting climate. And this is one of the ways that humans impact ecosystems, is by modifying climate. We talked about that just a little bit ago. And the authors state that human activities are modifying Earth's climate and changing the fundamental controls over ecosystem processes throughout the entire planet, often to the detriment of society. They include the detriment of society idea because the changes in climate that we're causing are causing really big impacts. And the effects are strong. And these often are detrimental. Some of them might be positive, some of them might be negative. But part of the reason that we're spending so much time thinking about climate as a discipline is because we know that ecosystems depend strongly on climate. And the things that we depend on ecosystems for are also being changed. And so these human activities and thinking about Earth's climate are important because the activities of humans impact climate. And they impact the ecosystems too. So as an example, the authors give Hurricane Katrina. This is a satellite photo of Hurricane Katrina over Louisiana, and this happened in 2005. And the toll from Hurricane Katrina was immense. On the order of 1,500 people died, and there's $50 billion of damage, something like that. And something like Hurricane Katrina, we can't state definitively that humans impacted Hurricane Katrina, but everything we know about how humans have impacted climate would say that Hurricane Katrina should have been more intense as a result of. And so in this case, it's important to think about climate not only for how it impacts ecosystems, but also societies. And those are atmospheric questions in many respects, but they're also ecosystem questions. And we're going to see how climate and ecosystems interact such that the consequences of our actions work through ecosystems to impact something like how large Hurricane Katrina might have been. One thing to think about, and as we go through this chapter and think about climate, it's important to understand that definitely climate is complex. There are many factors that end up determining how the climate is structured for a given area and how the climate system works. But that being said, it's not necessarily complicated. It's composed of many different parts, but the way that those interact can be understood relatively easily. There's just a lot of different parts that come together. In this chapter, we're going to go through the basics of climate and what determines climate and why it is what it is in different places. So it's complex, but not necessarily complicated, and we're going to try and break it down into its different components. Lastly, the authors in each of these chapters offer up a focal issue, something to focus your attention on and to understand why this chapter might be important. They say that human activities are modifying Earth's climate and changing the fundamental controls over ecosystem processes throughout the planet. So if you ask the question, why should we care about climate? Yes, it impacts ecosystems, but at the same time, it impacts those ecosystem processes that we as societies depend on. The types of questions that ecosystem ecologists would ask with regards to climate is what determines the distribution of Earth's major climate zones. So we know that, and we'll show that as we travel, we're going to see different vegetation types, different ways that ecosystems function. But we're not necessarily sure what it is about climate that determines these climate zones and why they're set up where they are. It's also important to think about why climate is changing and why different regions differ in the changes that are happening. So why do regions differ in the climatic changes they experience? These are really basic questions. They're fundamental questions that ecosystem ecologists and other scientists have been working on for a while, and we'll cover some of those here.